In today's video, we take a look at the Artillery Sidewinder X2 3D printer. Does a printer with a moving build plate of this size make any sense at all? Before we get into the review of this printer, I would like to say a few words. This printer was sent to me for a review. However, the printer arrived in a slightly damaged condition that limited its use. So I contacted support, who responded very quickly and sent a brand new printer. This video will focus on that second printer. All opinions in this video are my own. No one is paying me for the review and no one has any influence on the content of the video. Let's take a look at the contents of the package. The first thing I have here is a spool holder with a filament sensor. In this stylish little bag you will find a set of tools, spare parts and accessories for your printer. For reading, you will find here a very brief assembly manual. There is also a power cord that must not be missed. Now we come to the first part of the printer, and that is the fully assembled Z-axis with X-axis and the hot end. The second large part of the printer is actually the rest of the printer. This is the entire base of the printer with the Y-axis. We will take a detailed look at the components of the printer after it's assembled. To assemble the printer, we need to mount the top part of the printer to its base and screw it on with 2 screws from each side. We also need to connect the Z-axis motors and the filament sensor. The connector you see here was used for the Z-axis limit switch on the previous version of the printer. This connector can also be used on this printer in case the Z-axis calibration sensor fails. You just need to load new firmware into the printer and connect the included limit switch. Now you need to attach the filament holder. You must not forget to connect the filament sensor. Finally, we need to remove the zip ties from the Z-axis to release it and the paper covering the print surface. Now let's power up the printer and take a look at its parameters and the components used. The print area is 300 to 300 to 400 mm. The printing surface is a glass with a thin layer of silicon carbide known as a ultra base or carborundum. At the bottom of the glass we can find a silicon heated pad powered by mains voltage. The whole Y-axis is held by yellow springs on a carriage with 6 wheels. This carriage travels on a 60 to 20 mm aluminum extrusion, which ensures high stability of the travel. Compared to the previous version of the printer, the power cable of the heated bed is very well designed. The printer is controlled by a touchscreen. As a medium for the print files, you can choose between memory card or USB disk. As an extruder, there is a modified version of the Titan extruder in a direct version. As a hot end, there is a Volcano hot end with a nozzle diameter of 0.4 mm. This hot end should be able to give us a filament flow of more than 20 cube millimeters per second. The part cooling fan is a modified version of the 40 to 20 mm fan. The printer has an automatic calibration of the print surface flatness using a touch sensor. As a small bonus, there is an LED light. The entire X-axis travels on a 60 to 20 mm aluminum extrusion just like the Y-axis. In this case, it uses only 3 wheels. As with the previous version of this printer, there is a very well-made cable management to the hot end and X-axis. Related to this is the very clever use of the connector at the end of the Z-axis. In addition, the Z-axis has 2 motors that are connected by a belt at the top. As a bonus, there is a spool holder and a filament sensor. At the time of filming, the printer was on sale for $349. If you click on the link in the video description and use this coupon, the price will be reduced even more. From the manufacturer's website and European warehouse, the printer will arrive with free shipping within 2 weeks. After solving a few problems, which we will talk about later, I did the initial alignment of the print bed. Then I started printing files from the USB drive. First, I printed the Cube 3 model, which turned out to be a small cube with the Artillery logo on it. Getting the print off the already cold glass required applying some force. I'm not sure why this model has a brim around it, but taking it off was no issue. Looking at the walls, you can see the uneven layering. It doesn't look too bad in real life though. The transition to the new layer is perhaps better left uncommented. This is probably the ugliest transition to a new layer I have ever seen. The top layers look standard. The second prepared model I printed was this shape. I can't tell exactly what it is, but it looks like a small vase or enlarging screwdriver handle. The uneven layering is again visible across the entire print, and the transition to the new layer doesn't look great either. You can also notice very pronounced resonances in that print. We will talk more about these later. In any slicer, just make a copy of the profile for the Artillery Sidewinder X2 with BL Touch. Then it was time to create my own prints. The first one I printed, despite my dislike of the model, was the benchy boat. At the first glance, notice the very unpleasant filament stringing all over the model. This was printed on the original print profile with a very short retraction length for the Volcano hot end. After adjusting the profile, I tried printing again and the result was significantly better. Uneven layering and also resonances were also evident here. I will tell you right now though, it was visible in every print on this printer. Overall, this print turned out very well. Perhaps surprisingly well. For a printer of this size and with a relatively low price, it's actually a better result. The next print was this boat. To my surprise, the print again looked very nice. At first glance, you can see the cooling problem with layers with too steep an incline. This problem is seen mostly on the back of the print. Visible resonances cannot be missing in this print either. On some of the upper layers, you can see a slight filament flow problem. Filament stringing can be occasionally be seen. But again, I can say that the print turned out very well. The size of the printer already tells me that it is designed to print mainly large models. So let's try to print something bigger. For example, this beautiful model of a melting girl. Taking down larger models requires force. You will notice the filament stringing in some places when it travels between distant points. You will certainly notice what is called ghosting, aka visible resonances in the print. This can be seen very noticeably in the high layers of the print. But we will look at that later in this video. In general, the print again doesn't look bad. I'm not saying it's flawless or even perfect. I'm just saying that it doesn't look bad. I then printed these models, which are by the same author of the previous model. Links to everything can be found in the video description. Here is the same situation as the previous prints. Light filament stringing in some places, uneven layering and resonances, specifically in the higher layers of the prints. I was wondering if the filament stringing might be caused by the chosen filament rather than the printer. In the second print was actually everything identical to the first one. Again, I can describe both prints as very nice. You can't expect an absolutely perfect print from a printer of this kind and size. This printer is designed to print large models where the quality of the print is not a major concern, but rather the size of the print. This bear has been chosen on purpose and mainly because there are no visible layers. On the other hand, it gives us an idea of the dimensional possibilities of this printer. I must add though that the finished print does look really beautiful. Not to be stuck just with the standard PLA, I decided to try an elastic material as well. Since the printer has a direct extruder, this was no challenge either. The layers bonded beautifully and the print held on the heated bed with no problems. After printing these models, the printer was included among my older printers, which basically meant that when I needed to print something bigger, I used the area of this printer. Unfortunately, not all of the prints were perfect. For example, this print kept having a problem with layers being laid down where the pitch was too sharp. The poor cooling of the print didn't help either. Looking at the already printed parts, you can see that the print quality was fine. The problem really only occurred in places with sharp rises and in places where stronger cooling was expected. In this print, on the other hand, there was a problem with adhesion to the print surface. After cleaning the print surface with isopropyl alcohol, everything was fine. I would consider this to be a user error and therefore my fault. Since I wanted to use the potential of the volcano hot end, I tried to print faster. Unfortunately, more melted material required stronger cooling. However, the printer was not capable of doing that. If you want to avoid the cooling problem, print slowly. On printables.com I came across a very interesting model of a calibration cube with thread and nut. Out of curiosity, I printed it out. The print quality again looked like the previous prints. It wasn't perfect, but it also wasn't anything to be ashamed of. In addition, the nut went on the print without a problem. The gaps in the top layer of the nut were due to an improperly chosen perimeter generator in the slicer. The caliper tells me that the dimensions of the print are 19.9mm in the y-axis and 20.03mm in the x-axis. I also printed out my tolerance test just to be sure. The perimeter generator was still unchanged in the slicer and that's why you can see the gaps in the top layer. After tilting the print, you can see that 4 of the 5 cylinders have fallen out of the print. Only one remains, which represents a tolerance of 0.1mm. With a little force, this cylinder can also be released. On the cylinder, you can see that it was connected to the rest of the print in only a few points. So let's say that the tolerance of this printer is somewhere between 0.1mm and 0.15mm. Then I tried changing the filament during printing using the M600 command. To my surprise, unfortunately, the printer did not stop and continued printing. Next, I did a test of the filament sensor. To make it easier to demonstrate, I loosened the filament sensor from the spool holder. The filament sensor worked as expected. The print stopped and the nozzle lifted off the print. However, it remained standing in place. Using the menu, I needed to move the nozzle to where I wanted to load new filament. After the new filament was loaded and confirmed on the display, the printer resumed printing. I ran this test 3 times. This was followed by a test to recover printing after a power failure. After turning the printer back on, the screen displayed as if printing had just stopped. After clicking the resume button, the printer warmed up to print temperature. It then performed X and Y axis homing. And finally, it returned to its original position and resumed printing. I also ran this test 3 times. Now let's take a look at the result. All 3 filament changes went fine. Only the 3rd filament change was missing some filament at the beginning of the layer. The print recovery after the power failure was pretty much standard. Since this is a layer level print recovery, the last layer is reprinted after the print recovery. The heated bed and nozzle must have warmed up before any movement. This unfortunately left several damaged areas in the print. But let's be clear, any print recovery is always better than no print recovery. Specifically for prints that last several days. In order for any print recovery to work properly, it was necessary to uncheck the relative extrusion option in the slicer and remove the zeroing of the extruder position on the new layer. Otherwise, the printer always pulls the filament back to the starting position at the beginning of the new layer. So the printer prints, but no filament comes out of the nozzle. We haven't said anything yet about the noise level of the printer. I tested the printer's noise level in a 12 square meters room in an ordinary prefabricated apartment. The printer was placed on a walnut weiner table a few centimeters from the wall. For the measurements, I used a Wallcraft SL100 noise meter with a frequency range of 31.5 Hz to 8 kHz, set to measure sound at a dBA level that ranges from 30 to 130 decibels. Measurements were taken from a distance of 1 meter from the printer while printing a sample file from the USB drive. Under these conditions, the printer volume was around 45 decibels. Let's take a look at the components of which the printer is built. Probably the most interesting here is everything on the X-axis carriage. You will notice the direct Titan extruder modified to suit the needs of this printer. Attached to it is a hot end known as a volcano. The only bad thing about this is that it is not an all-metal version. We are therefore limited to filaments up to about 260 degrees Celsius. The all-metal version can be purchased as an upgrade on the Artillery website. There is also a 40 to 20 mm fan made directly by Artillery. Under the X-axis cover is an adapter between the data line and the X-axis components. Also, here can be found that very dim LED lighting. The BioTouch inspired calibration touch sensor can be seen here. Let's take a look inside the printer. First though, we need to break the warranty tape. At first glance, you will notice that there is not much hidden inside the printer's body. There is only the power supply, motherboard, touchscreen and the wiring. I was quite surprised that most of the components are custom made for the Artillery. As you can see, for example, on this screen. The motherboard is Artillery Ruby version 1.2. Unfortunately, it was not visible what the stepper motor drivers are. Well, except that they have a label Artillery Step version 2.0 on them. So I decided to look directly at the driver chip. I could only find original stepper motor drivers under this label on AliExpress. According to the discussions on the internet, it should be a copy of the TMC2100. And probably the last interesting component here is the heated print bed powered by mains voltage. An adhesive magnetic steel sheet with PI coating can be purchased for the printer. Why this printer enhancement is more than desirable, we will discuss in a moment. Let's now summarize the pros and benefits of this 3D printer. The first positive is definitely the size of the print area. This is also related to the heated bed, which can be heated up to the desired temperature very quickly. Another plus here is the direct extruder with Volcano hot end, which makes it possible to achieve high material flow and print elastic materials. Other pros definitely include the automatic calibration of the print surface, which helps solve problems with uneven surfaces. Also, let's not forget the filament sensor. Among the pros, we can also include two Z-axis motors connected by a synchronization belt. This should prevent the Z-axis from moving on its own and make Z-axis movement more precise. The option to choose print from a memory card or a USB drive will certainly come in handy for many people. and as a final benefit, the noise level, or rather the quietness of the printer. As I am sure you have figured out, the printer is not flawless. The first defect was waiting for me right after the printer was assembled in the form of an imprint on the X-axis wheel. Using a simple test, I found that the bottom wheel was to blame. There was a new one in the package, so it was no problem to replace the wheel. After replacing it and adjusting the appropriate pressure, the X-axis movement was fine. From room temperature, the bed heated up to 80 degrees in about 2 minutes, but speed isn't always everything. For example, how the heat is distributed and how the actual temperature is measured is also important. With this glass bed, I reached a temperature between 60 and 70 degrees after a few minutes of heating to 80 degrees. However, in the middle of the bed, I reached a temperature of almost 100 degrees. So in addition to uneven heating, I got temperatures I didn't really want. There is one big problem with the print surface that is permanently attached. Taking a print off such a surface is not easy at all, even when the surface is cold. To make it easier to take the print off the printer, I would recommend buying a steel sheet with a magnet. Not only will it minimize the possibility of damaging the finished print, but it will also improve heat distribution under the print. And this is really needed, as you have seen. The part cooling fan is, in my opinion, very poor for the needs of this printer. If you decide to print faster, you need to cool the print. That doesn't work very well with this small fan. With such a high Z-axis, you need diagonal supports and slow printing. Look at how sensitive the end of this axis is to vibration. This, of course, also happens during printing, as seen on most of the printed models. The table on which the printing and filming of the review took place is mounted to the wall. So it was really just vibrations caused by the movement of the printer. On Thingiverse.com you can find upgrades that users of these printers are installing. Among the first and most repeated upgrades are diagonal supports, better part cooling fan duct, improvements to the filament spool holder, and better filament routing. Since I do not have another print of this size, I will try to install some of these upgrades on this printer as well. But more on that in another video. You have seen both, the good and the bad. So it raises a question, does buying this printer even make sense? Unfortunately, I can't answer that question. Current market for printers of this size still has many shortcomings and is not as saturated as the markets for smaller printers. If you want a quality printer of this size, we would need to look at a completely different price range. So I will leave it to you to make your own opinion.